Hi, we are continuing with our part 2 of lesson 9.4. This is elimination by multiplication. In part 1, we learned elimination by multiplying one of the equations. So I focused on one equation. I looked at the variables and I wanted the same coefficient for one of the variables, and one of my variables looked promising. I had a 15 and a 5. The 5 was easily changeable to a 15 just by multiplying the entire equation by a 3. So I went ahead and did that, and it was easy for me to eliminate the y and then figure out what x is. Once I figured out what x is, I went and figured out what y is. So that was elimination by multiplying one equation. So part 2 is about elimination by multiplying both equations. Why do I have to multiply both equations now? So let's take a look at this system. 3x plus 2y is equal to 1. 4x plus 3y equal to -1. So when I look at these two equations, I cannot eliminate any of the variables by just simply adding the two equations or subtracting the two equations. None of them will get eliminated. 3x plus 4x, x will not get eliminated. 3x minus 4x, so x is not going to get eliminated. 2y minus 3y, the y is not getting eliminated. 2y plus 3y, it's not getting eliminated. So just by simply adding the two equations or subtracting the two equations, it's not going to eliminate my variables. So let's try multiplying one of the equations. For me to change one of the equations, I should have a promising variable. For example, if I look at the first equation, I have a coefficient of 3 for x. The 3, I cannot change it to a 4 just by multiplying it by a whole number. Similarly, the 2, I cannot change it to a 3 just by multiplying it by a whole number. So if I want to eliminate the x, I should either be able to change the 3 to a 4 or a 4 to a 3. It's not possible. Or if I want to eliminate the y, I should be able to change the 2 to a 3 or the 3 to a 2 just by multiplying one of the equations by a whole number. It's not going to happen. So what can I do? So I want to change one of the variables to have the same coefficient in front of it. So can I change both of them then so that it becomes the same? So what can I do? I'm going to look at the least common multiple for 3 and 4. Which is the least common multiple for 3 and 4? Yes, that's a 12. So I'm going to look at my least common multiple. Least common multiple. So I'm assuming that, okay, I want to eliminate the x. So I want to find the least common multiple for 3 and 4. The least common multiple for 3 and 4 is 12. So if I can change the 3 to a 12 and the 4 to a 12, I achieve my goal. I have the same coefficients in front of my variable x. So to make the 3 to a 12, I have to multiply the first equation by 4. And to make the 4 to a 12, I have to multiply the second equation by a 3. So what will happen if I multiply the first equation by 4? 3 times 4 will give me a 12x. 3 times 4 will give me a 12x. 2 times 4 will give me an 8y. Is equal to 1 times 4 will give me a 4. Now this becomes my equation 3. If you look at closely, my equation 1 and equation 3 are equivalent to each other. They are one and the same. The next equation, 4x plus 3y equal to -1, and I'm multiplying it by a 3. So 4 times 3 is going to give me a 12x. 3 times 3 is going to give me a 9y, equal to -1 times 3 is a -3. Now this becomes equation number 4. So equation number 2 and equation number 4 are equivalent to each other. So now when I look at equation 3 and 4, So instead of using 1 and 2, I'm going to use 3 and 4 and then solve my system. So when I look closely at equation 3 and 4, now this looks promising to me. So I have the same coefficient in front of my variable x. So same number, I have the same sign, which is a positive 12. So that means I have to subtract. Integer addition subtraction, very important. 12x minus 12x gets eliminated. 8y minus 9y will give me a negative 1y equal to 4 minus negative 3. 4 minus negative 3 will give you a positive 7. So negative 1y is positive 7. So divide by negative 1, I got y is equal to negative 7. So I found out what y is. Now I have to go back and plug this value into one of the equations. As you can see, I have 4 different equations now. I have 1, 2, 3, 4. I have 4 possibilities for me to plug the y and figure out the x. I can plug it into any one of them because equation 1 and equation 3 are one and the same. Equation 2 and equation 4 are one and the same. And the solution to one of the equation is the solution to the other equation. So it should work for both. So if I plug in y equal to negative 7 in any one of the equations, I can figure out what what x is. So I have 3x plus 2 times negative 7. I am putting it in equation 1. 3x plus 2 times negative 7 equal to 1. Or 3x 2 times negative 7 is negative 14 equal to 1. So I add the 14. I get 3x is equal to 15, or x is equal to 5. So I got my solution 5 comma negative 7. The solution is 5 comma negative 7. So we started off with 2 equations. We couldn't eliminate it as is. So I went ahead and multiplied both equations so that I can get a common coefficient for one of the variables. Then I can eliminate that variable by simply adding it or subtracting it. So now you may ask me, why did I eliminate the x? Why can I not eliminate the y instead? Can I do that? Of course, you can do that. So I have 3x plus 2y equal to 1 and 4x plus 3y equal to negative 1. I am taking the same 2 equations. Earlier we went ahead and found the least common denominator for 3 and 4 and tried to eliminate the x because those were the coefficients of x. Now if I want to eliminate y instead, I could do that too. But now I have to look at the coefficients of y. The coefficients of y are 2 and 3. So what is the least common denominator or least common multiple of 2 and 3? The least common multiple of 2 and 3 is 6. Alright. So I'm going to change both of them to a 6 so that I can eliminate that y. So to change that to a 6, I have to multiply the first equation by a 3. And to change the 3 to a 6, I have to multiply the second equation by a 2. So if I multiply the first equation by a 3, I get 9x plus 6y equal to 3. That's my equation number 3. If I multiply the second equation by 2, I get 8x plus 6y equal to negative 2. Same thing, right? So let's go ahead and try to eliminate the y. Now when I want to eliminate the y, I have the same number, the signs are same. So same number, same sign, I'm going to subtract. So 9x minus 8x is going to give me 1x. 6y minus 6y is going to eliminate that. 3 minus negative 2. 3 minus negative 2 is going to give you a 5. So 1x is 5, or simply x is 5. So I solved for x. If you look at our previous solution, we had x equal to 5. Exactly the same. So now I know what x is. I'm going to figure out what y is. Now same thing. I can plug in the x value into any one of these equations. Equation 1, equation 2, equation 3, or equation 4. It should work for all 4 of them. So if I plug in the value of x, I'm going to use my equation 1 again. Or let's try equation 2. Will it work? Let's just check that. So I'm going to plug it into my equation 2. 4 times 5 plus 3y is equal to negative 1. 4 times 5 is 20 plus 3y is equal to negative 1. So subtract the 20, subtract the 20. 3y will be negative 21. So divide by 3 and get y equal to negative 7. So my solution is 5, negative 7. I had the same exact solution when I tried to eliminate the x. 5, negative 7. So you could eliminate any one of the variable you want. Feel free to do so. Alright? Or you want to check both ways? Check both ways if you have the time. But during the exam, it's enough to do one way. Alright? So, but show all the steps. That's elimination by multiplying both equations. So that's part 2. Enjoy studying.